Today we're going to be talking about how to determine whether two lines are parallel, intersecting, perpendicular, or skew lines. And in this particular problem, we've been given two lines, L sub 1 and L sub 2. Each of our two lines are defined by these three parametric equations. So L sub 1 is defined by these three parametric equations for x, y, and z, and L sub 2 is defined by these other three parametric equations. As you can see for L sub 1, our parameter value is t. We have this parameter value t in all three of our parametric equations. For L sub 2, we have a parameter value of s. So that's going to be important later on. We just want to make a quick mental note of that. Now, how are we going to test to determine whether our lines are parallel, intersecting, perpendicular, or skew? Well, I've gone ahead and written out the steps that I like to use to test for these things. I like to do them in this order because I really am starting with the simplest and quickest test and then narrowing my way down to my conclusion. So the first thing I like to do is test to see whether or not the lines are parallel. If they are parallel, then we don't have to test for anything else. We know that they're parallel, we can be done. If they're not parallel, if we use our test and we conclude that the lines are not parallel, then we move on to our test to see whether or not the lines are intersecting. If they're not intersecting, then we've already ruled out parallel and we've ruled out intersecting, so we can conclude that the lines are skew lines. We don't have to go any farther. Remember that when you have two lines, they must be either parallel, intersecting, or skew. There's no other option. They can't be all of these things. They can't be none of these things. They can't be two of these things. They have to be one of these three options: parallel, intersecting, or skew. So when you rule out parallel and intersecting, if you do, then you know automatically that the lines are skew lines and you can be done at that point. Perpendicular is kind of an offshoot of intersecting. You can think of parallel, intersecting, and skew as three options. The lines have to be one of those three things. If the lines are intersecting lines, they may or may not be perpendicular, right? They could be intersecting, but at some angle other than 90 degrees, right? But they may be perpendicular lines. So if during your testing for parallel, intersecting, or skew, you conclude that the lines are intersecting, then you can move on to test for perpendicular. Sometimes you're asked to do that. But right now we're just going to start with parallel, then intersecting, then skew. So the first thing we want to do, test for parallel. I'm going to show you how to test for each of these things, but the way that we're going to test for parallel, we're going to take the coefficient values on our parameters, which are also called our direction numbers. We're going to take the ratio of each and set those equal to each other and see if our equation holds true. So here's what we mean by that. We're going to take the coefficients on our parameter values. So remember, our parameter values were t and s for L sub 1 and sub 2 respectively. Well, the coefficient on t here is 2. The coefficient on s here is 4. Both of these parametric equations are equations for x. So what we want to do is take the ratio of these two coefficients. We're going to say 2 over 4, like this. Then we're going to set that equal to the ratio of the coefficients on our parameter values in our y equations. Here in front of t, we've got -1. We always have to include the sign here, so we've got -1. In front of the s, we've got -2. So we say -1 divided by -2. Then we set that equal to the coefficients on our parameter values in our z equations, which are 3 and 5. So we say equals 3 over 5. Now, if this equation is true, we know that our lines are parallel and we don't have to go any farther. If this is not true, then we can rule out that our lines are parallel. We can conclude that they're not parallel and we move on to our test for intersecting. Well, if we simplify this, we can see that 2 over 4 simplifies to 1/2. -1 over -2 simplifies to 1/2. But 3 over 5 doesn't simplify, doesn't reduce to anything further. This is not true. 3 over 5 is not equal to 1/2. So this equation here is not true, and therefore we can say that our two lines, L sub 1 and L sub 2, are not parallel. So I'm going to write over here, not parallel. That means we need to move on to our test for intersecting. If you find that they're parallel, you can stop, you're done, you don't have to test for anything else. Since ours are not parallel, we'll test for intersecting. Well, how do we test for intersecting? The way that we do it, we need to try to solve a system of simultaneous equations. If we can solve it, then we know that our lines are intersecting. If we can't solve it, we can conclude that they're not intersecting. So here's what that looks like. We're going to take each of our three parametric equations and set the equations for x equal to each other, set the equations for y equal to each other, and set the equations for z equal to each other. When we do that, we're going to get 3 plus 2t is equal to 1 plus 4s. We just took these two equations for x and set them equal to one another. We'll do the same thing for our equations for y. We'll get 4 minus t is equal to 3 minus 2s. For z, we'll get 1 plus 3t is equal to 4 plus 5s. Now, how are we going to solve this system of simultaneous equations? Well, the easiest way to do it is to take our first equation and solve it for one of our parameter values, either t or s. Let's take this one and solve it for t. The way that we're going to do that, we'll subtract 3 from both sides, and we'll get 2t is equal to 4s minus 2, because we get this 1 minus 3 is a negative 2. Then we'll divide both sides by 2, and we see that we get t is equal to 2s minus 1. Now we have a value for t that's in terms of s. We want to take that 2s minus 1 value and plug it in for t into our second equation. So we're going to take this second equation here and plug in our value for t. So we'll get 4 minus right here. And then in place of t, we'll plug in 2s minus 1. The value we just found, 2s minus 1, is equal to 3 minus 2s. Now you notice that we have an equation that's entirely in terms of s. We've eliminated the t value. We want to go ahead and solve this equation for s. So what we're going to get is 4 minus 2s plus 1. We get minus a negative 1 is plus 1 equals 3 minus 2s. Now, if we add 2s to both sides and we consolidate our constants on the left-hand side, over here on the left we've got 4 plus 1, which is 5. We subtract 3 from both sides and we get 2 on the left-hand side for our constants. We added 2s to both sides. That's going to cancel it from this left-hand side. And over here we get negative 2s plus 2s is a 0s. So essentially, 0s is just 0. We get 2 equals 0. Well, automatically we know that's not true. It can't possibly be true. So we've already found a fault in this system of simultaneous equations, and we show how it can't be true. Sometimes you'll get a value for s, right? Maybe you get like s equals 1. You can plug that back into this value here and get a value for t. Let's say you get s equals 1 and t equals 0 or something like that. When you get those two values, you can then take those two and plug them into your third equation here, the 1 plus 3t equals 4 plus 5s. Plug in your values, your constant values for t and s, and if this equation is true, then you know that you have a solution to your simultaneous equations and that the lines are intersecting. But if you get a nonsensical answer again like this, then you know that your equations are not intersecting. We didn't have to go that additional step because we already found a problem in that 2 does not equal 0. So because we get this nonsensical answer, we know that our lines are not intersecting. Because we've ruled out that they're parallel and intersecting, we know that they must be skew, because remember, it must be one of these three things. So because they're not parallel and not intersecting, we have skew lines. So we can say that we have skew lines here, and we could be done. If we had shown that they were intersecting and we wanted to test for perpendicular, if they were intersecting and we wanted to know whether or not they were exactly perpendicular or not, here's how you test for perpendicular. You want to take the dot product of L1 and L2. So it looks like this, L sub 1, L sub 2, taking the dot product of those two. Remember that when we take the dot product, we want to take the sum of the products of our direction numbers. So remember we said that these were our direction numbers, the coefficients on our parameters like this. So what we want to do is multiply these together. So 2 times 4, we'll do 2 times 4. Then we want to add to that the product of the direction numbers we get from our y equations, which again, remember are negative 1 here and negative 2. So we want to say negative 1 and negative 2, and then add to that the product of our direction numbers from our z equations, 3 and 5. So 3 and 5 like this. If the value we get here on the right-hand side is equal to 0, then we know that our lines are perpendicular. Not only are they intersecting, but they're exactly perpendicular. So when the dot product of our direction numbers is equal to 0, our lines are perpendicular. If this value is not equal to 0, then we know that they're not perpendicular, they're intersecting lines, but they intersect one another at an angle other than a perfect 90 degrees. So let's see here. When we simplify, we get 8. -1 times -2 is a +2, so we get +2, and then plus a 15. And we can see right here that this is going to be not equal to 0. That means that our lines are not perpendicular, which of course they wouldn't be because we already found out that they're not intersecting. They're skew lines, so they can't possibly be perpendicular to one another. But regardless, if you find that they're intersecting, that's how you test to see whether or not they're perpendicular. And that's it. That's how we determine whether lines are parallel, intersecting, perpendicular, or skew given parametric equations for both lines.